are going to take the seminar on the topic pairwise independent events. We are already going through the chapter probability, right? So probability helps us to discuss about the uncertainty and randomness. In probability, we already discussed about random experiments like tossing coins, throwing in one cube, and taking a card from that, etc. So we already come through different kinds of events. Sometimes the events will influence the probability of another event, and sometimes it may not. In probability, if the occurrence of a event doesn't affect the probability of another event, we call it as independent events. So in probability, we can explain the independent events in many ways, and among them it is pairwise independent events. So here we are going to discuss about pairwise independent events. So as the name indicates, we are discussing about pairwise independent events. So here we are considering a pair of events. That is, just consider events like A1, A2, A3 up to AN are different events of a random experiment. So we can say that for a pairwise independent events, the definition can be explained as P of AI intersection AJ equal to P of AI intersection P of AJ. So it is the condition for pairwise independent events. And in probability there is a topic like mutual independent events, right? So it will be taken by Aneena. Yeah. So there are some similarities and dissimilarities between the mutual independent events and this topic. That is, for a mutual independent event, the condition is given by P of A intersection B of A intersection B intersection C equal to P of A into P of B into P of C. But for a pairwise independent event, we only consider any two events of the whole event. So we can write it as P of A intersection B. According to this condition, we can write it as P of A into P of B. Similarly, we can write it as A intersection C as P of A into P of C. And last, P of B intersection C can be written as P of A into P of C. Is it clear? So, can we move to an example? Just consider a random experiment of tossing two coins, and there are and the sample space can be given as SH, TT, TH, and HT. The first event is getting the first coin as head. So it is SS and HP. Second event is about getting head as the heading. The second coin is head. So it will be SS TX. And the last event is given by both the faces are same. So it will be SS TT. So probability of getting A is P of A 2 by 4, that is 1 by 2. and P of B is also 2 by 4, that is 1 by 2. And P of C is equal to 2 by 4 again. Can we just prove that if these events are pairwise events? So we can prove whether this condition is mentioning here. So P of, just first consider A intersection B. What will be P of A intersection B? That is HS, right? So it will be 1 by 4. So RHS is 1 by 4 and LHS is given by P of A into P of B. So 1 by 2 into 1 by 2. That is 1 by 4. So this can be set as pairwise independent events. So next also can be set as P of B intersection C, that is HS and HS, that is 1 by 2, 1 by 4. Similarly to this, and the P of B into P of C is also like this. So we can neglect that. So each of these pairs are pairwise independent events. Is it clear? So we can move to the questions. First question is, a die is thrown. Let A is an event of getting an even number, and B is getting a number greater than 4, and R, A and B are independent. So here the sample space is 1, 2, 3, 4, 5, 6, right? It's all about throwing a die. So the sample space is this, and getting a even number. The event A can be written as even number 2, 4, 6. And the next event is greater than 4. That is 5, 6. And probability of getting A is equal to 3 by 6. That is 1 by 2. And P of B equal to 2 by 6. That is 1 by 3. So we have to prove the condition, that is P of A intersection B equal to P of A into P of B. P of A intersection B, that is, what is common here? Only 6. So 1 by 6. Then P of A is 1 by 2, right? So 1 by 2 into 1 by 3. That's also equal to 1 by 6. So here we prove that both the events are independent each other. So the next question is, if A and B are independent, show that A and B complement are independent. Here it is given that A and B are independent. So we have to prove that P of A intersection B complement is equal to P of A into P of B in the B complement. So by just considering the figure A and B, we can say that A intersection B complement can be written as what? A intersection B complement, that is A minus this part. So A minus A intersection B. So the probability of A intersection B complement can be written as P of A minus P of A intersection B. It is given that A and B are independent, so it will be P of A. This will be equal to P of A into P of B. So we are taking P of A outside, so it will be 1 minus P of B. So 1 minus P of B is equal to P of B complement. So hence it is proved P of A intersection B complement is equal to P of A into P of B complement. So they are independent events. So can we move to the last question? That is, a card is drawn from a standard deck of 52 cards. Let A be a event. Card is heard. And B be a event. The card is a king. Check whether A and B are independent. So we know that there are 4 types of card in a deck. That is heart, diamond, club and spades, right? So the probability of getting a card is heart. That is what? There are 52 cards, right? So there will be 13 heart cards. So 13 by 52. That is 1 by 4. And getting a king, there are 4 kings in a what type of card. So P of B will be 4 by 52. That is 1 by 30. So we have to prove the condition P of A intersection B equal to P of A into P of B, right? So here P of A intersection B, the card will be a third key. So P of A will be 1 by 52. And what about P of A into P of B? 1 by 4 into 1 by 30. That is 1 by 52. So both the LHS and RHS are equal. So the condition is proved. So that's all about my topic. Thank you.